Hi, I'm going to tell about the HoughTransform and boundary detection. The HoughTransform is a way of detecting lines in images. The simplest way of looking at the HoughTransform is that you draw a set of parallel lines throughout the window and then sum up the intensities of the pixel that each line crosses. Now let's have a look at this window. On the left side of the window I have drawn some parallel lines. The way of getting a HoughTransform is to sum up the intensities along each of these lines, getting a one-dimensional spectrum. Doing so for different angles gives us a whole spectrum. As you can see, I'm varying my X position of the mouse on the right side of the window. Now, each position along the X-axis will correspond to one angle in the original image. Now, when I say intensities, it isn't really a meaningful term, because the HoughTransform usually just operate on binary images. So, in order to get a binary image from the image we want to compute the HoughTransform of, we will use the Sobel operators. This is what the Sobel operators look like. We have one filter for the X direction and one for the Y direction. So we compute two images consisting of the intensities we gain from using these filters, and then we combine them using this formula. After all that, we threshold the results and get the binary image we are looking for. Now, suppose we have a rectangle like this, and suppose we want to compute the HoughTransform of it. The first thing to do is to compute the binary image containing the edges using the Sobel operators. Then we will end up with something like this. The next step will be to compute the transform itself. Let's have a look. Now, let's have a look at this picture. Recall that every pixel in the Hough space can be thought of as a line in the original image. Those bright pixels in Hough space correspond exactly to the lines that overlap with the lines in the original image. The X-axis in the Hough space corresponds to angles in the original image. As you can see, we have bright spots at the left side of the Hough space, in the middle, and on the right side. These corresponds to 0 degrees, 90 degrees, and 180 degrees projections. The first and the last of these spots are actually equal, only flipped, because a projection along 0 degrees is the same as a projection along 180 degrees. The fact that these spots are 90 degrees apart fits well with the fact that we are dealing with a rectangle. Now that's all for the HoughTransform, but before we end, I would like to show you what happens if we don't restrict the HoughTransform to work on binary images, but also on grayscale or RGB images. That is called a random transform.